Okay, so today our topic is accuracy and precision. It is a part of chapter 1, unit and dimensions. In our previous lectures, we studied about measurement of length, we studied about measurement of mass, we studied about measurement of time. So today is a totally new topic, which is accuracy and precision. So it's very interesting topic, quite typical. I will not say it's a difficult topic, but it's a typical topic because both the terms, accuracy and precision, they appears to be similar. So, but these are different from each other. So we will study how these two terms they are different from each other, and in our day-to-day life, how these two terms are very important, and even in the experiments in the research, they plays very important role. So first, I take how we can define accuracy and precision. Generally the people they perceive these two terms similar terms, but they are entirely different terms. Mathematically they are different terms. So if we take the accuracy, how accurate a particular value is, so accuracy can be defined as it is numerical value obtained on measuring any physical quantity or quantities depend upon the measuring instruments and method of measurement. So accuracy of any physical quantity, it is a numerical value obtained during any measurement. Suppose we are measuring the length of a road with the help of a scale. So what value we are getting, that is the uh, measured value. Now that value will be accurate or precise. That is the topic of our discussion. So, a unit of measurement of a physical quantity is the standard reference of the same physical quantity which is used for the comparison of the given physical quantity. Now, exactly what is the meaning of accuracy and precision? So, let us go for that. So, first, accuracy, it refers to how closely a measured value agree with the true value, because there is a true value for any physical quantity. There is a true value for any physical quantity. Suppose we are measuring acceleration due to gravity in our experiment. There is a true value for that. Small g is equal to 9.8 meter per second square. Small g is equal to 9.8 meter per second square. So this 9.8 meter per second square, it is the true value. Now in our experiment, what we are getting, that will be our observed value. And our observed value, that may be accurate, that may be precise. That is the topic of discussion in our today's lecture. So accuracy refers to how closely a measured value agree with the true value, and precision refers to what limit or resolution the given physical quantity can be measured. So by definition it seems to be very difficult to understand the difference between the two, but with the help of this example, one example I have here, we can understand the meaning of accuracy and precision very clearly. So let us take a road. I take a road whose true length is given. Exactly, exact length or the true length of that road is 5.346 centimeter. This is given length. This is the true length of the road. Now, two persons they are doing two experiment. Ram measure with a meter scale of least count zero point 0.1 centimeter and find length equal to 5.3 centimeter, because Ram has the meter scale meter scale whose least count is zero point 0.1 centimeter. Least count means the minimum value which we can read on that scale, that is called the least count. So minimum which we can measure with the help of our meter scale, with the help of Ram's meter scale, it is zero point 0.1 centimeter. So with that meter scale having least count zero point 0.1 centimeter, Ram find length of the road equal to 5.3 centimeter. Now it's term of Sham. Sham measure with a vernier caliper. I told you that vernier caliper is also used to measure the length of the object. So with the help of a vernier caliper, whose least count is zero point zero 0.01 centimeter, means the minimum value which can be measured, minimum length which can be measured with the help of this vernier caliper, it is zero point zero 0.01 centimeter. This is the meaning of least count, the minimum readable value on a scale, minimum readable value on a scale, that is called the least count. So you, in this case, vernier caliper is of zero point zero 0.01 centimeter, and Sham find length is equal to 5.24 centimeter. 5.24 centimeter. You write centimeter, I forget to write centimeter here after 5.24. So make it correct, it is 5.24 centimeter. So in the first case, length is equal to 5.3. It is very close to the true value. So see the true value. True value is 5.346 and Ram's value is also 5.3, but it is 5.3, that is 5.346. So Ram's value is very close to the true value. So that's why it is called the accurate value. It is called the accurate. We will call it accurate but less precise. It is accurate means very close to the true value but less precise. Now, what is the meaning of less precise? We will understand when we will see the Sham data. And Sham data shows L is equal to 5.24. 5.24. 5.24, it is not close to the true value because true value is 5.34. It is 5.24, but it is more precise as compared to the as compared to the Ram value. Why? Because in Ram data, after the decimal, only one digit is there. Here in the Sham data, after the decimal, we are having two digit, means two significant figures. If more significant figures are present, then that value will be more precise. If less significant figures are present and the value is close to the true value, then that is called the accurate value. So I think it will be clear. I repeat it once more. What is the difference between accuracy and precision? Both appears to be similar terms, but they are entirely different. Accuracy refers to how closely a measured value agrees with the true value. Means whatever a measured value is there of any physical quantity, if it is close to the true value, then it is said to be the accurate value. But what is the meaning of precision? Precision refers to what limit or resolution. What limit or resolution? Resolution means the more and more number of significant figure present in our data. So if more and more number of significant figures are present in our data, means more and more digits after decimal points are there, then that value, that um, physical quantity, that will be more precise. So in this case, we took a road of true length 5.34 centimeter and Ram measure with a meter scale of least count zero point 0.1 centimeter and find the length of the road equal to 5.3 centimeter, which is very close to the true value. So this L is equal to 5.3 centimeter. It is the accurate value. But in Sham's data, L is 5.24 centimeter, which is not close to the true value, but it has more number of significant figure. So more number of significant figure means this value is more precise. So this is the difference between accuracy and precision. So it means when we are observing any data, when we are observing or when we are measuring any length, any mass, any time, so it is not sure that our measurement that will go to the that will exactly be equal to the true value. So it means we are near about the true value in terms of accuracy and precision, but we are not getting exactly the true value. So if we are not getting exactly the true value in our measurement of any physical quantity, so it means we are having errors. This is called error. If the observed value or the measured value is not exactly equal to the true value, it means we have error in our measurement. So the next slide that is the topic of discussion, error in measurement. So how we can define error? So the basic definition is uncertainty of measurement is technically called as errors. Uncertainty of measurement means uncertainty in getting the true value. The measured value or the observed value is not meeting exactly with the true value, so that is the error. So uncertainty, not surety of measurement is technically called as error. So now type of error, we have two types of error: error in observation and error in instrumentation. So I will discuss this error in observation and error in instrument with the help of a general example. I already discussed the same example. It's a very simple example. Suppose I want to measure the distance of a tree from my room, from my bedroom. So roughly I will see the tree through the window of my room, and I will have a rough estimate in my observation that so and so is the length of the tree from my bedroom. With the help of my eye, I will make a judgment that this may be the length of the tree from my bedroom. But in my observation, it is not necessary that the it is the real value or it is the true length. So definitely there is an error which is called error in observation. The second is error in instrument. Suppose I take a scale. I have a scale, I have a meter scale, and with the help of that meter scale, I try to find out the distance of the tree from my bedroom. So I can do some mistake in the measurement also if exactly uh, it is not started from the corner of the bedroom to the stem of the tree or the exactly the body of the tree. So if they are not exactly touching, if there is some disturbance or some inaccuracy in my scale, or even the scale is broken, some part of the scale is broken, so it is not the exact scale. So in that case again I will have error. So that is called the error in instrumentation. So basically, two types of error are commonly observed: error in observation and error in instrument. Even in the instrument, in the scale or any weighing machine, there may be some error. Even the weighing machine that is not properly balanced, that is not at the balance position. So even the instrument that carry the error, and that error that will be communicated in our measurement. So let us take one example. Suppose we want to measure the density, and we know density is equal to mass upon volume. So, if we want to measure density accurately, then it is necessary to measure mass as well as volume accurately. So, the accuracy in the measurement of mass and volume, that will decide the accuracy in the measurement of density. You take any physical quantity, if that physical quantity is derived from any other physical quantity, then the second physical quantity or the third physical quantity or the fourth physical quantity will decide the accuracy of the first physical quantity. Suppose we take another example. Force is equal to mass into acceleration. So accuracy in the measurement of force, that will be decided by accuracy in the measurement of mass and accuracy in the measurement of acceleration. Take another example. Pressure, which is equal to force upon area. So accuracy in the measurement of pressure, that is decided by accuracy in the measurement of force and accuracy in the measurement of area. So for any physical quantity, the accuracy depends upon the other physical quantity which create this physical quantity, which make the physical quantity. So it is important to work on the other physical quantity which makes the main physical quantity. So further we categorize error into two categories. There is another categorization of errors which is called systematic error and random error. So what is systematic error? Systematic error, it is created by the instrumental error. If there is already some error in the instrument, suppose we are using ammeter and we want to measure the current. So we have to check that the pointer of the ammeter, that should start from the 0 ampere. But if it is less than or more than the zero, means it is in the left side of zero or it is in the right side of the zero in the beginning of the experiment, so it will create the instrumental error. It will give the error in the measurement. So if it is exactly at zero, the pointer is exactly at zero, you take voltmeter, you take ammeter, or you take galvanometer. If the pointer is exactly pointing on the zero, then it means zero error, means no error. But if it is either in the left side or in the right side, then it may create an error. Suppose if it is in the left side of the zero, then it means all the values in the left side of the zero, they are negative values. So in this case, we will get a negative error. But if our pointer is a little bit in the right side of the zero, so all the values in the right side of zero, they are positive values. So here our instrument, that will give the positive error. So systematic error, having, they can be created with the help of instrument. If there are already some error in the instrument, that will be the instrumental error. The second error is error due to imperfection. Imperfection means, suppose if we want to um, purchase a, mm, a teapot, and already if there is some heat loss in that teapot, in that kettle, so again that will give the imperfection. So already it means the walls of the kettle, the walls of the container, they are not perfectly insulator. So it means already there are some defect. If there is any defect in the operators, in our device, in our instrument, any defective instrument, that will lead to the error, and that is called error due to imperfection or error due to defect. Already some defect are present in our instrument. The next is called gross error. Gross error, it is also a very important error. Suppose we are doing the experiment and we are changing the position of the operators we are changing the labeling of the operators. Initially the level of the operators in our lab that was different, but after 5 or 10 minutes we change the level, means from one side or from the other side there are some changes in the height of the operators, or there are some changes in the room temperature, or there are some changes in the current flowing in the apparatus, or some heat change in the apparatus is changed during the experiment. So if there are any changes, which is called the improper adjustment of experimental setup, means we are doing the experiment with just casual approach. Um, we are not doing the experiment with proper focus. Just casually we are performing the experiment. So the gross error that may arise, that is also the part of systematic error. Now second category is random error. It is arises due to small changes in the condition of the experiment. Small changes in the condition of the experiment or incorrect judgment of the observer. So, incorrect judgment of the observer. I have one beautiful example. Suppose we are measuring the weight of a body with the help of a spring balance, and in the spring balance, our pointer is um, indicating in between 20 and 25 kilogram, in between 20 and 25 kilogram. So if it is exactly in the center, the pointer is exactly in the center, then it is the value is 22 and a half. But the observer who is observing this pointer, if he is not focusing properly, and then he may get the value either 22 or 23. So he will get the rough value. He will not get the accurate value, because for the accurate value he has to note the accurate position of the pointer. The pointer is in between 25 kilogram and 20 kilogram. So there are five division between 20 and 25 kilograms. So accurately, precisely, we have to observe, we have to check the position of the pointer. So if we are not accurately or precisely checking the position of the pointer, then the error is called the random error. So this was the two categorization of the errors. One is the systematic error, and other is the random errors. So both the errors, they may create a problem in our observation. Now errors are not required. Errors are not needed. They are creating a problem. They are giving us a false information about any physical quantity. So there is a need to reduce or to minimize the errors. So here there is a method of minimizing random error. Random error can be minimized. So if we repeat the experiment many times, and every time we are getting a value, and suppose we are performing the experiment and we did the experiment 10 times, we have 10 values, we have 10 readings. So large number of readings of that physical quantity, even in every reading we may have errors. So in 10 readings, in every reading we may have error, but here we have a set of 10 readings, and in those 10 readings we may have two types of error, either positive error or negative error. So if measured value, I already told you, if measured value is greater than the true value, then it is a positive error. But if measured value is less than the true value, then it is a negative error. For example, if true mass value is given, if true mass value of any physical quantity, it is 10.05 gram, it is the true measured mass. But in the first measurement, if I get 10.15 gram, So 10.15 gram, it is greater than the true value, so it will show the positive error. In the second measured value, I am getting 10.02 gram, and 10.02 gram is less than 10.05 gram. So this is a negative error. So it's a very simple categorization uh, of errors. Positive error means the measured value is greater than the true value, and negative error means the measured value is less than the true value. So in our case, the true mass is 10.05 gram, and first measured value is 10.15, which is greater than the true value. So this is a positive error. And in the second category, the measured value is 10.02, which shows negative error. Now, the final and last slide of today's lecture, method of expressing error. How we can express the error mathematically. So we have four ways of expressing error. The first name is called absolute error. The second is called mean absolute error. The third is called fractional or relative error. And fourth is called percentage error. So this topic, method of expressing errors, this is very, very important because we have to solve the small numericals of these four types of errors. In our curriculum, in our syllabus, we will find in our exam some numerical. So numerical will come from this part. So that's why this part is very important. Even you appear in any competitive exam after your 12th class, so numericals, they are taken from this part. Even the conceptual question, they are taken from this part. So this part is very important. And in our next lecture tomorrow, we will discuss every part, all the types of expressions of error in details. So that will be our tomorrow lecture, and that's all for today. So let me take the attendance. uh, Manoj Thapa,
Present, sir.
Ayush Dhiman,
Present, sir.
Payal Chauhan,
Present, sir.
and Shefali Dhiman,
Present, sir.
and Suhani Thapa,
Present, sir.
and Vaibhav Kohli,
Present, sir.
and Vansh Moria,
Present, sir.
Vansh Bijalwan, Vansh Bijalwan, Vansh Bijalwan, unmute yourself. Vansh is absent, but he is showing here. Anybody else? Anybody else? Vansh, are you there?
No, sir.
Yes,
Yes.
sir.
Vansh,
Yes,
are
sir.
you there?
Yes,
Vansh
sir.
Bijanwan.
Yes, sir.
Okay. 6, 7, 8. So again, we have 8 students today. So total 8 students are there in the class. Maximum attendance till now we have 8 students. Okay, so we will continue with the expression of the error in our next lecture tomorrow. That's all for today.
Thank you, sir.
Okay.
Thank you, sir.
Okay, sir.
Okay.
Thank you, sir.
Okay. Okay. Bye.
Bye, sir.
Okay. Bye.